So today, hopefully, we're going to take a slightly less than serious look at machine fault diagnosis and healthcare. So as you can see today, I'm not dressed conventionally as the rest of the people, and hopefully why am I dressed like this will become clear as we move forward. So I'm going to take a look at how we look at the future of machine health diagnosis, particularly using PI and set point. So let's start with some questions. From a healthcare perspective, a personal healthcare perspective, do we know how healthy we are today? Do you have an indication of how healthy you are? So put your hand up if you visited the doctor within the last year. Okay. Keep your hand up if you've had a health check from a doctor, or it was just for us. If it was a health check, keep your hand up. 1. If it was sickness, so some of you have been to the doctor a few times, yeah? So most of us don't like visiting the doctor, and we only go when we're ill, unless you have that annual health check. So let's look at some healthcare statistics. 20 to 45% of people who have a serious issue with their heart don't know it. So there could be some conditions that you don't understand, you don't know, and you could even, a silent heart attack is defined as one where there may not be symptoms, or the symptoms you exhibit may not be those that you associate with a heart attack. So in the spirit of healthcare, heart attacks are similar to having a machine breakdown. So the question I have, if you look at your machinery, your particularly rotating machinery in your plant, are you actually giving your machinery the same kind of healthcare that you would give yourself? So typically, if you go to the doctor may perform some basic measurements on you. So he's gonna listen. He's gonna listen with his stethoscope. He's gonna listen to your heart, take your blood pressure, maybe some vital statistics, which will give him a rough idea if you're in good shape. A good doctor is going to dig a little bit further. Maybe they're going to listen to your heart with some machinery. They'll also ask you questions about what's your diet been? Are you a smoker? Are you a drinker? How much exercise do you take? Every one of those pieces of data will improve the context of the diagnosis that the doctor gives you. If we take that analysis and then move it to machinery, traditionally, machinery was run, we do planned maintenance on it, and potentially we may have some condition monitoring programs. So old school would have been, there's a guy that walks around the plant and takes a number of measurements from the machine. That's your basic level of, I have a sensor on the machine, I take some data from the sensor. If I take it over time, I will build a picture. But in between, there's a lot of time where you actually don't know what's going on with that machine, and there can be faults that develop during that time that can quickly develop into that silent heart attack that stops production for you. If you take a little bit more advanced machines, generally in industries like oil and gas, most people have been doing condition monitoring for some time. They're aware of the benefits of it, and their machines will be very well instrumented. So there's a lot of other machines in the plant, and there's already a lot of predictive maintenance programs which start to collect data and then fail because they either don't correct data, or they start to collect too much data and people get swamped by so many false alarms that they lose trust. They lose trust in the measurements that they make, and quite soon people switch off the condition monitoring systems. But on a recent survey that we carried out in conjunction with a market research company, we worked out only 30% of people, maybe in the same spirit as the heart attack, really know the exact condition of their assets at any one time, which leaves them liable to those very costly breakdowns. So again, we surveyed people. This came from pharma, oil and gas, and there were some various different measurements, but up to 250,000 of an hour of lost production in some very expensive industries. So we're here to talk about condition monitoring. Why would you bother to do condition monitoring? And many of you may have seen this PF curve in the past. What we're trying to look at is that point P on this diagram is when failure begins. And many of us will have experienced things where machines are getting hot, you can hear a noise in the fault domain. said by that time, by the way, you're having a heart attack if you're in that final third. If you get to the middle third, you're in the point where perhaps you can make some changes to your lifestyle, or you can take actions to your machine that will prevent you reaching the third domain. And if you look, there's things in here, infrared, oil debris analysis is one, but the fact that you're collecting debris from machinery probably means that you've already got an issue if debris is starting to come off. Let's look at the part where my world begins from here, which is vibration analysis. You can see that it's not the earliest way to detect machine problems, but vibration itself doesn't just detect too much vibration in a machine. There are a whole host of conclusions you can draw from vibration data, especially when you combine that in context with other data you may have from the machine, particularly that in your PI system. And I'm going to cover that as we go forward a little bit more. So typically benefits, we started with the walk around program. Putting people into your plant at any time is dangerous thing to do. Why would you walk the person to the data when you can bring the data to the place where you want to analyze it? Secondly, I've talked about faults and heart attacks, but really the biggest value you can get from condition monitoring is not to tell people that you're going to have a breakdown, it's to tell them you can keep running. You don't need to do a maintenance. The cost of the breakdown is not the issue here. It's the fact that, do you have the confidence to say, miss that maintenance? Are you able to keep running? And if you can do 1 or 2 maintenance savings a year, the benefits are actually massive. Certain regulated industries, and we work with a pharmaceutical company who are doing investigations into whether or not they needed to do a maintenance. The OEM who supplies the machine would tell them, you must maintain and change a bearing every 6 months. If they don't do that, then they're in danger of not being compliant with FDA regulations. So they have to follow the manufacturer's instructions. So part of my company is involved with being owned by a bearing company. So as well as condition monitoring, what we did was take a look at the bearings that they take off the machine and say to them, did you really need to do that maintenance? What we found is the bearing life was about 20% of the life. So there's 80% of good time left in that bearing. The second thing we found, that every single time you touch a machine, you now bring the risk of somebody doing something wrong. So I used to work for the photographic people, Kodak, and I can still remember my time as a maintenance manager. There was one engineer, Salvatore, his name was. Yep. Every time he completed a maintenance, he would come back to the workshop with 2 or 3 bolts in a box left. And we said, well, what are they? We don't need them. We don't need to put them back on the machine. Well, they came out of the machine, yeah, but we didn't need to put them back again. And you can be sure that within a day or two of this guy, we started to do some analysis on it and looked at which products, which shift was Salvatore on, yeah, and what was the uptime for the production equipment on the weeks that he works. And fortunately, Salvatore retired over that period of time, so I didn't have to do any further work on there. But there's a whole lot of context around what you do and when you do it, which will help you make that decision that simply says, doctor, how long have I got? Which is really what we want to know. Can I keep running? So the consequence is we extend the life of the assets, we maintain when we should, and we increase uptime. So in some cases, you'll see many of the PI partners out here today who are in the world of data science, machine learning, artificial intelligence. So they may be able to build models for you. If you look at people with new science, would you trust AI to diagnose your heart at the moment, or would you want to go to a heart surgeon? And I guess the question is, how good's the AI? How well have you built the data model that you're looking at? And for us, our company's been going about 80 years, and we're able to give the advice in our world that would be the same as a heart surgeon. So if you want to find a cardiologist in the USA, you're fortunate, there's about 25,000 cardiologists, but not everybody's a cardiologist. In our world, the people who are qualified to look at vibration, they start from number 1, and you could call category 1 a first aider, up to number 4, these are the cardiologists, and there's about the same amount of them. But not every company wants to invest in somebody that confirms diagnosis, because your business is making the products that you make. It's not doing vibration analysis, checking that the models work correctly. You just want to get to that simple answer that says, how long have I got? Do I need to stop now? So for us, we've been collecting data for a number of years. I see there's a small wind turbine running outside of here. Well, currently, we've got 35,000 wind turbines monitored in the world. We've been collecting data for the past 20 years. And one of the challenges you get with a new piece of equipment is you have to build that model. You have to get the data, and you have to check that the model is predicting accurately. What we've done here, we're in the process of effectively digitizing 20 years of knowledge. And before we start with the machine learning and the artificial intelligence, the easiest way to improve reliability is build on the experience that you have inside your organizations already. If you haven't digitized all of those people that we see since COVID now that are leaving the industrial space, we've got a big problem that we've got a leakage of knowledge. So many people with so much experience are leaving the industry, and we haven't digitized. So when you've monitored 35,000 units for 20 years, we pretty much know what the signatures are of almost every fault condition that you will have with a wind turbine. So the first step is build in what you know, digitize it, and then use that to inform your people of how long have I got? Have I seen this problem before? And we've seen most of them, but not all of them. So I believe if somebody tells you that they've got a perfect AI model, you really shouldn't be trusting that. It can massively improve it, but I still think there's a place for human intelligence in our diagnosis until we get this perfect. So what do you need to create what we call an actionable insight? And there's an element of trust here that says if you're going to collect data and you're going to then shut down one of your plants or miss a maintenance, you need to have a high level of confidence in what you're doing. So first of all is how much data do I need to collect? Should I be collecting the data constantly? And if in the world of Pi, we have a particular patent where we can collect vibration monitoring data and put it into a Pi server. Now, you may say, well, in our world, there's a thing called a time waveform, which is the basic measure of vibration analysis. When you look at this, it would just look like mess on a screen. Somehow you need to transform that into something that you can look at. In order to do that, you'll perform certain mathematical equations on it, look at it in the frequency domain. You'll boil it down to something that you can understand, which is a trend. And some of those trends will be looking at not just vibration, but looking at different elements of the machine. Many of those 5, 10, 20 common faults, and you would then be trending for each fault. How likely is it that I've got a problem with the bearing on the drive end of the motor? But when you've transformed it, usually something like Pi can't absorb that data. It's too high frequency and too much, or you'd fill up your Pi server in no time whatsoever. So when you're collecting the data at the correct frequency, what we do is compress it. We only look at the changes in state of the data. We compress what is almost a video stream into something that is very small and that can be put into Pi. Why do you need that? Because I'll be honest and say we don't pick up every fault. And when you see something that you believe this is the first time I've ever seen this fault, it would be nice to go back in the same way as you would with a video feed and unpack that data and say, I think it's a new fault, but can I go back 5 years, 10 years? Can I use my model to look back and say, the signature for this fault is new. We haven't seen it before, but now that we've worked out how to find it, that becomes part of your model. So if you look, you need to collect the data depending on the criticality of the machine. So I'm looking at my stethoscope here, which is actually not connected to anything. So this is a wireless sensor. So simple assets, you connect with wireless sensor. This may only give you 1 or 2 readings a day, but it's enough. It's enough for a simple asset. As you go through from the auxiliary assets to the semi-critical assets, you need to be creating probably more data. You need to be taking more measurements because you're looking for more complex faults. And so based on the criticality of the asset, you will just connect enough so that you can monitor changes over time in this asset. And if you miss something, the reason for putting the data into Pi and compressing it is you can always go back. You can always go back in time and look at it. So filtering it. Another important thing to stop overloading your system is that you turn on and off the measurement, gated. You gate the measurement. Why would you? I've got an example where we looked at a train, monitoring the bogies on a train running along. You can't monitor them in the station. Why would you monitor a machine that stops? When the train goes around the corner, it's an unusual, there's load on one side, not on the other, because you're cornering. So you only want to collect data during a particular either steady state or known condition, so that you don't waste data, and you have to have somebody clean out all of that rubbish from your data set. Now we come to the context, back to Salvatore. Once that data is in Pi, it looks like any other data tag that you have in Pi, and you can now look for vibration conditions. What product was I running? When was the machine last maintained? And by Salvatore or not by Salvatore, you can bring the speed of the machine, the load of the machine in there, and the context that you have is that you can look at that all in a single time zone. Otherwise, the alternative for vibration analysis is many people have a separate system, and you have those surgeons who sit in a dark room for us, those vibration analysts, that you have to try and build a report to say, how can I match the data together so that I can get to the answer in the fastest possible time? And I would say again, 90% of problems we're not looking at because they're automatically triggered from there. So your heart surgeon, whether that's an internal heart surgeon or whether that's somebody else that you employ, yeah, is able to help you either by looking at it as a service for you, or the alternative is that you're taking that data from Pi, sending it and having your advice, your professional advice, as and when you need it. So let's look at a practical example of how this works. What you're seeing here is probably a network that's looking at maybe pumps, and it could be a factory the size of this room that we're in at the moment. The basic point is you've got to collect data. So the simplest way to do that is easily mounting wireless sensors. Low cost, wireless. The wireless sensor isn't really the trick here. But assume you put a number of wireless sensors in, you connect these wireless sensors to a gateway, and out of there you're collecting these all-important time waveforms. Now comes your choice. If you go to I think there's a pointer on here. Yep. Your choice here. You want to collect that data into Pi and you do the analysis yourself. What we would provide you is a toolbox that from within the Pi system, you can pop up all the analytic tools that you would need to do normal vibration analysis, but you never leave your Pi Vision world. So you have a toolbox that just simply is available to you as part of what we do. That's not something, unlike AVEVA, I know that this is not something you buy, this is something we give you to help you analyze. And behind that, for that few percent that you can't diagnose, you've either got your own in-house expert. The alternative is we've built the intelligence that we have and the 20 years of data and knowledge into our own cloud platform. And you could pick a combination of using our cloud or our experts, or alternatively using the AVEVA Pi system, from which you're also combining data from process, data from MES, data from your maintenance management system. And typically, out of that vibration, you would be able to find, in some cases months ahead, misalignment, imbalance, bearing defects, soft foot machine mounting, a whole host of electrical faults that are simply available to you by monitoring a bearing. So the question is, who should deliver the healthcare for you? And the answer is it depends. Some people have an interest in becoming completely self-reliant. I've worked with is anyone here from BASF? No, I know BASF is a big customer that we work with. they've got 20 people in a remote monitoring centre. They see this as a. Many people think, I don't want to do that. It's not really what our core focus is as a company. So they will completely outsource that. So as you go through that training from Cat 1 to Cat 4, you can get to the point where you're either totally standalone and you build your own in-house expertise, or you choose to buy rotation as a service, for want of a better word. And you just say, guys, monitor my plant. Do I need to do anything? Tell me if I need to do anything, or just can I keep running, simply. So if you're not sure, this is when you get to that last one. I'm pretty sure that if I thought I had a heart condition, I wouldn't go straight to open heart surgery. And sometimes the temptation is shut the machine down, rip the machine to pieces. That's something that we really want to avoid. And by giving you the confidence to make decisions, you will know whether you need to keep running, whether you need to stop. So for me with Pi, our partnership with Pi is effectively putting that data into a place where it's accessible to you, where you can view it in context with all the other conditions of your machinery, and potentially to avoid maintenances, keep your plant running, make more money for your company.